So we have region R bounded by y equals to x squared, y equals to 0, x equals to 1, x equals to 2. R is rotated around y-axis. Volume of a solid. I'll do firstly by shells. So we have our region y equals to x squared, piece of parabola between x equals to 1 and x equals to 2. And we're rotating it around y-axis. Okay. Then we almost immediately know the answer. Integral 2 pi r h dr equals around y-axis, r equals to x, h is going to be in terms of y. If you just look at the original interval, you have only two y's, y equals x squared and y equals to 0. So basically, the only possible answer will be h will be x squared, or h equals to x squared minus 0, so which is equivalent. So that's your initial guess without even looking at what's going on. Now let's try to actually do the drawing. So drawing will look like this, parallel to, when we do shells, we do parallel to axis of rotation. Then we have 2 points on the bottom, x and 0, points on top, x and y. Then we rotate. Try to do it one more time. Should be wider. Okay. Then you definitely see that's the height. And that's your radius. Radius is x because it's horizontal. Height is vertical, so y. And essentially, we are ready to do the integral, to write integral. Integral 2 pi xy dx. And you can easily read right from the beginning or from that picture that x is between 1 and 2. And again, if you look at the picture, then you know that y equals to x squared. Then we got an easy enough integral 1 to 2 pi x times x squared dx. That integral should not be too difficult to calculate. Take 2 pi out, do it from 1 to 2, x times x squared is x cubed. 2 pi, x to the 4 over 4, from 1 to 2, so 2 pi, 2 to the 4 over 4, minus 2 pi, 1 over 4, so 2 pi, 4, 2 to the 4 minus 1, 2 pi, 4. 2 to the 4 is 16. 16 minus 1 is 15. 15 pi. Something along these lines. Because integral was not difficult to set up, not too bad. And after you got an integral, it's easy enough integral to do. sorry, this example is slices, right? As some of you point out, I put it wrong, it's slices. Difficulties arise right from the beginning. Because if I try to draw my interval, then you see here my left boundary comes from that y equals x squared curve. But when I do it here, my left boundary will come from a different curve. It will come from a curve x equals to 1. So right from beginning, I'll have to split the problem into two pieces. I have to split it. And I will have to rotate the top part. And I will do rotation of the bottom part separately. That's already more confusing. So I'll have to do it in two pieces. Okay. I mean, it's doable. Let me try to do it. Then I'll do the first piece firstly, I guess. Second problem is, oops. I'll need to find endpoints. Previous example was shells, now we're doing slices. Sorry, guys. And the previous example was shells. Right, so you see that's already confusing because we have to divide in two. So I'll try to run through. Here we need to find the boundary. So you know, here x equals to 2, x equals to 1. Curve is x squared, so 1 squared is 1 and 2 squared is 4. 1 and 4 for y-axis. And if we do this one, I'm going to get integral dy, because we're going to be slicing y-axis. Inside, we're going to see shell, not shell, washer. You see washer. So it's going to be pi x squared right minus pi x squared left. And y will be changed from 2 to 4. So that is going to be equal to, from y is changing from, sorry, 1 to 4. 1 to 4 dy y. X to the right is 2, so 2 squared, minus x to the left is, comes from equation y equals x squared, so square root of y. We'll be able to finish this one. So that was referring to the first one. And second one, it's kind of straightforward because it's kind of your x equals to 1 here and x equals to 2 here. So it's integral, again, dy. Y will be changing from bottom, which is 0, to 1, pi 2 squared minus pi 1. Should be able to finish. So you see in this case, shells were so much easier than the slices because we have to end up with dividing by slices. Let me run a similar example where we'll do the same region, but as soon as we'll rotate around x-axis, slices will be easy. Okay, so let me do the same similar example. Same region. So we have y equals x squared, x equals to 1, x equals to 2, y equals to 0. So this region, is rotated around x-axis. Volume. Let's see why shells here is going to be not so nice. Y equals x squared, x equals to 1, x equals to 2. We are rotating around x-axis. Trouble with this one is when you try to draw your pieces parallel to axis of rotation, your region on the left will be changing. So that's why it's going to be harder. We'll have to split that into two regions depending on the boundary. Have to split in two. Okay. That's where you probably stop and say, how about I'll try slices? Oh, how about slices? Draw our region. We rotate around x-axis. We do interval perpendicular to axis of rotation. And you see our boundaries are not switching. We don't have different boundary. We still have the same curve on top, and we still have straight line on bottom. And it's even better. It's going to be disk. So we almost immediately know what the answer is going to be here. So the answer is going to be integral pi r going to be y pi y squared dx, and x is changing from 1 to 2. And y will be x squared. Okay, and you see big slices, you'll get something going on almost immediately. So usually, again, shells are easier, but not necessarily. So try both and see for each problem which one is going to be working better. Shells around y-axis. We're going to see dx. Slices around x-axis. We're going to see dx. Okay, so, and that's kind of easier, more standard way of having things. If you're rotating around x-axis and you get dx, and usually you have function y in terms of x, you don't have to manipulate anything. Another thing which you might think, if you're rotating around x-axis, maybe slices will be better because you already know that is going to be dx. If you're rotating around y-axis, maybe you want to try, and you want to have dx, maybe you want to try shells. Okay, because what's the point? Just imagine if you do shells around x-axis, you know what you're going to get the y advent. And if you have function given to you, say y equals to f of x, then essentially you have to solve it and find what is x in terms of y. Right? And it's not always the easiest thing to do. And the same is true when you do slices around y-axis. You're going to get dy, and again, expression here will depend on x you'll have to express x in terms of y because you have to do substitution, and that will be y equals f of x. So somehow you'll have to solve it for x. And again, that's depends on the function.